So much like velocity, forces can be split into components. If you remember back to two-dimensional motion, if we have a ball that rolls off of a cliff or off of a table, that ball is going to trace a path that looks like this. The velocity in the x direction is going to be constant and positive if this direction is positive. And the velocity in the y direction, well, there's no velocity in the y direction to start with, but then it gets faster and faster as it travels down, and so the velocity in the y direction will look like this. So this idea that we can split the velocity into x and into y, that's called the components of the velocity. We can split forces into components just like that. So here's my guy pulling on this box that's stationary. This is definitely one of my favorite examples, favorite scenarios. Let's go ahead and add an angle in here. And so let's say that this box, this man is pulling at an angle of 35 degrees. The free body diagram of this, always start with a free body diagram. If we have the force of gravity on the box pulling downwards, we'll have the force of tension pulling at this 35-degree angle, and we have the force of friction backwards. And then we have the normal force. Because this guy's pulling up on the box, the normal force will be less than the force of gravity. So maybe it looks like this. What I'm really mostly concerned with, though, is this sideways force, this angled force, this force of tension. So I'm going to draw it nice and big here. Okay, here's my force of tension. We're going to split this force of tension into its two components, into its x component, the bit of the force of tension that is in the x direction here. We can look at our free body diagram and draw that in sort of dotted. That would be the bit of the force of tension that's in the x direction. You see it's sort of the shadow of this arrow onto the x-axis. We would call that FTX, or the force of tension in the x direction. It's a long name, but we can just shorten it up here. Then we can look at this and we can say, okay, well, I want to look and find the force of tension that's in the y direction. So it's going to be the shadow here. That would be for the y direction, the y component of this force of tension. If I draw it big here, this will be FTY. All right, so if the angle here is 35 degrees, how do we find the components of these two sides? How do we find how big this side would be? Well, we have to use trig functions. So sine, cosine, and tangent. I hardly ever use tangent, so it'll just be really the sine of the cosine. And so think about your SOHCAHTOA you learned in math. That sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. The adjacent side, that's the side that is next door to the angle. So if I'm at the angle, the adjacent side touches the angle. So this is going to be my adjacent side. And then the opposite side is the one that the angle looks across to. So this is my opposite side. If I were to think about, well, what would the sine of this angle be if I had the sine of 35 degrees? That's going to be the opposite, FTY, over my hypotenuse. In this case, this is my hypotenuse. The overall force is always going to be the hypotenuse, force of tension. Multiply both sides by the force of tension. I get FTY, the force of tension in the y direction, is the overall force of tension multiplied by the sine of 35. Okay, now the other component, once you've figured this out, that the force of tension in the y direction is the sine, the other component will always be the opposite, or the other trig function. So this one will automatically be the sine, the cosine, I mean. So I can go ahead and say, okay, well, the cosine of 35 is adjacent force of tension in the x over the hypotenuse, FTY, multiply both sides by the force of tension in the y, and I get the force of tension in the x direction is FTY cosine 35. Now, if you had a number for that force of tension, maybe the force of tension is 15 newtons. Remember, newtons is the unit for force. Then we would just substitute that in right here. We would say 15 newtons times the sine of 35. And we would say 15 newtons times the cosine of 35. The one thing worth pointing out is that once you plug these numbers in, unless you have a 45-degree angle, you'll always have a long side and you'll have a short side. So with this angle being smaller than 45 degrees, FTY is going to be smaller than FTX. You can double check once you plug your numbers in that that is in fact true. 8.6 newtons is the force of tension in the y, 12 newtons is the force of tension in the x direction.